Hey mechatronics students, in this robot video we're going to be talking about some of the details related to different motion control options when you're recording points. So let's dive right into some of the details here. So inside of the manual for the Fanuc robot we have this page 189, and it talks about the different types of motion instructions that are out there. So a couple of the details here. When it comes to motion types, we have a few options: joint, linear, and circular. So let's talk about the differences between those three different types. So the first one is called a joint move. It is the most efficient style of move for the robot to make. When we record a point and another point, the robot is going to move all joints at the same time to get there in the fastest possible manner. It may not be a straight line, and if you're going from a high point to a low point, it may take an arc as it's traveling down there, but essentially it's going to move all the axes as it needs to get from one point to the other, and not necessarily in a straight line. So the other one that's out there is called linear, or L. A linear move, when we have one point and another point, it will actually move in a straight line from one point to the next. So that would be great. Let's say that we're doing a welding on the seam of something, and it wouldn't be good to have a joint move if we're trying to get from this point, this corner, to this corner. We'd end up going up and over, taking its most efficient way to get from one point to the next. Not a good move if you're trying to do some welding. So if we want that to happen, what we'd like to see is it basically following that line all the way across from one point to the next point. That's a straight linear move. The last option that's out there is called a circular move. So that is used to form arcs and circles. And we'll show you how to define each of those. And we're going to do this by creating a program that's called Shapes. And we'll be able to see the differences between a linear, circular, and joint moves. So we'll use all three different types to create our program. So let's get into it. So first thing I'm going to have to do is zoom out a little and get the joystick, or the teach pendant, fired up here, so that we're going to create a new program. So we're going to go ahead and do a select and create a new program. We're going to call it Mech Shapes. Okay, so program name, we're going to go to our options in keyboard, and we're going to underscore Mech Shapes. Alright, so we got the name done, hit exit, and we're ready to go. I can hit the enter key to get into the programming mode. Alright. Sorry. So the first thing we're going to do is devise a plan. So when we look at the pattern that's set up over here, this is the shapes pattern that we're going to try to follow. So what I'm going to do is use these inner three shapes: this diamond, this circle, and this square. So the square I'm going to set up and do that in a joint program, so that it will just go from one point to the next point using joint motions, and it will take the most efficient way. So you're going to see it may not go in a straight line from one point to the next. It would deviate a little bit off and get from one point to the next as efficiently as possible. The next one we're going to do is a linear motions. So I'll go into this diamond in the middle, and we'll program each point here using linear motions. So it would go from one point to the next, and it would have to follow this line as it goes across. And then finally we'll do a circular motion with this center circle, and we'll see how to program those three different shapes. So let's get into jogging the robot, and away we go. So first thing I'm going to do is bring my Z-axis down. Oh, I've got to turn my teach pendant back into teaching mode. All right. I'm going to jog the robot down. There's times I wish it would go faster, but it is what it is. So I'm going to get close without going into the table. So we said our first one that we're going to do is to program this outer circle, or outer square, in a joint mode. All right. And I guess I don't have to get so fussy with it. Okay, so that would be my first point. So go ahead and do a shift point, and then by default in the program, it records that as a linear motion. Okay, so we've got an L over here, and what I need to do is to change that. We were going to change all of these into joint motions. So we'll go ahead and change it from linear to joint, and that should be just fine. And we'll talk about these terminations based on if they're going to be fine or continuous, and you can see the difference. Fine, it's going to actually get to that point and stop. Continuous, it's just going to take a bigger arc across there. So that might be interesting to have these set up as continuous. Okay, so you got the first particular line has been recorded as joint, position number 1, 90% continuous motion. All right, so we're going to go ahead and jog out to the next one. That's just an X positive. So there's the robot. We're going to jog X positive. Very good. And we're going to do a shift point to record that. And back to the teach pendant menus. By default, these things are all going over here to joint, or to linear, and I have to swap them manually to make them joint. And again, I'm just going to change it to continuous variety here. Okay, that should be good. And we just keep going, jogging the robot around to our next point. And that should be a Y motion, Y positive. That's good enough. And back to the teach pendant screen. We'll do a shift point on that and change it from joint or linear into joint. And I'm making all of these continuous. Okay, and back to jogging the robot. So it should be a X minus. And shift point, record that. And I'm just going to go ahead and change that to joint. And make it continuous again. And then we're going to put one more point in the program, and that'll go back to point number 1. So to the joystick here, or the teach pendant, okay, there are the different lines, and I put in one more point at the end here that I'm going to change into a joint variety, and just have it go back to position number 1. So number 1 and enter. and make that continuous as well. So that would be a joint move, and what we should be seeing with these is that it takes the fastest way from one point to the other and it doesn't follow a line. So we can go ahead and run this and see just what does that look like when we're running the program. So I'm going to go ahead and switch it up so you guys can see, and perhaps zoom in so you get a nice perspective of what that looks like. All right, so we're up close and personal with this, and we're going to go ahead and run the program. Wow, that 100% continuous, it really did an interesting thing there. So I'm going to change the percentage of continuous here, where it says CNT 100% there. We can change that number. So I'm going to hit enter, or see if I can just enter a new value, like maybe 10%. Hit enter. So I'm going to change all of these to 10% because that really took some short corners. So changing all of these from continuous 100s to continuous 10s. And that should get closer to the points. Okay, so we're going to go ahead and run that program again, this time demonstrating it with 100% continuous. So I still see it veering off a little bit as it goes from one point to the next. It's following it a bit closer, but it's still taking some arcs across there. So again, I just want to highlight the difference between joint moves and linear moves. So that's one. The next one that we were going to do was to take this, I may as well just do the diamond in the middle here. And we'll record that as straight linear moves. So that'll be nice because we won't have to change them to default there. So we'll go ahead and run the joystick or the robot to those points. Okay, pretty happy with that. So I'm just going to do shift point record, and that's going to put all of them in here as straight linear motions. So I'll just go ahead and program all 4 points so you guys can see they are going to be L's for linear, and you can see the designation how it's going to get there. So let's go ahead and record these points. So shift point to record. Now we're going to go X positive, Y positive, shift point to record that. Got a couple more to go. So X negative to get to the next value. So there it is, and shift point. And then I'm going to have it go back to the original point. Again, this diamond, it started up on point number 5, and we're going to end at that point as well. So I'm going to do another shift point, and this last one, I'm going to update this so instead of a new point, it's going to go back to point number 5. Hit enter. So it starts at 5, goes to points 6, 7, 8, and then it goes back to 5. And that should be a straight linear motion. So let's take a look at that program being run. and the differences between linear moves and joint moves. All right, so it's definitely following those straight lines to get from one point to the next, and it's not taking the most efficient. It's just going from one point to the next point in an exact straight linear motion across there. So that's the difference between linear versus joint. And then finally, we have the circle or arc commands, and we're going to go and show you what those look like. They're kind of interesting. So we're going to record these 4 points that have the little center marks on them, and then we'll update those so that we can run them as separately, or as an arc. Okay, so the first thing is just to record them as regular points, as regular linear, and then we'll get into the menu and update them. So I'm going to move back here. Looks like that's the next point, so I'm just going to hit Shift Record. We'll move to the next one. Shift Record, or Shift Point, I guess. Shift Record, and our last point over here. And there we go. So now the last 4 points I recorded are those 4 points on the circles. So let's take a look at how those points are changed from linear points into circular arcs. So all we have to do here is it's these last 4 points on lines 11, 12, 13, 14. So instead of linear, I'm going to change them to circular. And it's going to go from point 9 to 10. And then the next line, we're going to make that circular. And it's going to go to point... oh, wait a minute. I goofed that up a little bit. Sorry about this. We have to go to a point just regularly first. So the beginning of your circle is going to be a straight linear move. The next one is going to be a circular move, and that's where we go to 10 and 11. And then finally, the next circular move is going to go to points 12 and then back to point number 9. And then we can delete these other lines. So that's a edit command and delete that line. Yes. And edit command, delete that line. Yes. Okay. So those are the 4 points. The first point of your circle you're going to get to by using a straight linear motion to get there. So point number 9 is the beginning of this. Then the circle is going to be points 10 and 11, and then the next circular arc is going to go from 12 back to 9. So let's give that a run here. So I'm going to go up to that linear motion right here. Get on that line of line 11, and we're going to go ahead and drive it there. So I'll show you what that looks like over here. So a linear motion there, and there's the arc to get across there. You see that it paused over here, so that's actually a little bit interesting. I'm going to change that from a the first circular arc, I'm going to change its termination from fine to continuous. So in here, right there where the cursor's at, it says fine. I'm going to change that to an option of continuous, and then it should just roll right through it. Okay, so let's see what that does for our change. So it shouldn't pause there anymore. It should just go right through continuously across. So that's an example of a circular arc. So what we do is the first point we get to in a linear fashion. Then the next 2 points are part of a circular arc. And then, since we left off here, the next 2 points are another circular arc. So it's kind of interesting how those work. The only other thing I'd like to do is to add some additional, basically have it park itself in between each of these moves. So I'm going to add some position registers inside of there. Basically drive the robot home, go home, make the outer square, go home, come back, make that diamond shape in the middle using linear, go home, and then make the circle. So we can edit these programs inside of the teach pendant. So if I wanted to have it go home here, I need to insert a line above that, and that is a I believe it's an edit command, and insert. So go ahead and insert a line. Just one line should do, enter. And I've got a blank line up here that I can add a position register to, or the home point to. So I'm going to do a shift insert. Oops. I wanted a shift point. And that one, I'm going to change that from the type here. I'm going to make that into a position register. Whoa. And go to position register number 1, which I know is the home. So starts at home, runs out, does these 4 points in joint mode to make that outer square. Then the next one, we need to have it go back home as well. So I'm going to do another inserting of a line. Okay, and put another point in there. And update that point so that it is a position register type. So choice, PR, number 1. And the last one before we get into that circle, I want to insert a line here. Got off topic here a little bit. And that's going to be choice position register again. Okay. So in between all those moves, we're going back to our position register number 1 home position. So this is what it should look like when we run the program. Let's go ahead and do this. So from the home position, go out, make linear moves, and you see it's not following that line exactly. Then go back home. Coming back down, now we're going to do that inner diamond, and those are going to be straight linear motions. So it should follow the lines precisely. Go back home. And then the last one it's going to do is these arcs. So circular arc moves. And I didn't have it going back home after that, but I sure could have. Very good. So those are some of the commands that we can use to create different joint motion control instructions. We saw the difference between joint style moves, linear moves, and circular moves. So those are the three main types of moves that we can have with the robot. And we learned a little bit about the differences between the two, that joint moves are going to take the fastest way to get there, and it's not a straight line. Linear motions will be a straight line from one point to the next, and arcs are a little bit funny to program in there. They require us to use a few different points, and you saw how that was done. So in the lab, you guys are going to replicate these same things, have to follow some different shapes and patterns, and get from one point to the next. So good luck with that, and we'll catch you next time.